first of all, thanks for joining us today. We are gonna explore Java programming for database developers with virtual threads, R2DBC, and reactive strings. So without further ado, let's get started. Let me share my screen. Perfect. So my talk is about how to create 21st century Java database applications with virtual threads, reactive strings, and many good APIs and the specialized JDBC driver that we have, for Java developers. My name, as I said, is Juarez Barbosa Jr. This is my Twitter handle. I have 27 years of experience as an IT professional, in software engineering and also developer relations. Previous employers, sorry, Microsoft, Oracle, a couple of times, IBM, a couple of times, Nokia, Unisys, Accenture, and a few startups. Before rejoining Oracle recently, I was working for Microsoft as a developer relations lead. And I've worked for IBM as a mobile tech evangelist and cloud rockstar in Europe, tech evangelist and global thought leader for IBM Mobile. In the past, I used it to collaborate with the Nokia community concerning smartphone development, and I'm a lead software architect and DevOps um, architect as well. My expertise is in Java, cloud, DevOps, and blockchain. Okay, so let's talk a little bit about Java application development with the Oracle database. The interesting thing you can see here on the right-hand side is that Oracle database, we call it a converged database because at the end of the day, regardless of the data and the content type that you want to store, for example, if that's JSON, or if you are talking about the relational database or NoSQL, whatever, or spatial data, Oracle provides, the right solution for you because you don't have to have 2 or 3 different databases. At the end of the day, the Oracle database can support all these types of workloads. So you just need the Oracle database as your data store and your backend. And concerning Java, Oracle and the Oracle Cloud Infrastructure, we support Java with, I would say, the modern development frameworks, things like Spring. We have also Halidon. We can work with the other frameworks like Quarkus and so on. We support all the tools as well with some specific plugins for IntelliJ, Eclipse, and so on. We have an interesting project by Oracle Labs, called GrawVM, which is a polyglot runtime virtual machine, that you can compile your Java code, for example, to run as native code. So the performance is really fantastic. We support all the, I would say, build tools as usual concerning the Java ecosystem, things like Gradle and Maven, as you can see here. But let's talk about database access with Java. And then just to give you a glimpse of what we'll be exploring today, actually, there are 4 different solutions and APIs that I can talk about. But today I'm going to explore virtual threads, because recently Oracle released Java 19, JDK 19, and we have included as part of that what we call virtual threads, which belongs to Project Loom as the umbrella project. And virtual threads, they provide lightweight threads. And I have a very interesting demo here to allow you to understand what I'm talking about. But you can see that there are very, I would say, specific and different and optimized ways to create database applications and interact with the Oracle database. We can use, of course, as usual, the standard JDBC API, the classic one with synchronous and blocking JDBC calls. So when you have the, I would say, the a query, for example, in a kind of execution and response concerning the entire round trip for your query or your SQL update, whatever. That's a blocking call, and it uses behind the scenes what we call now platform threads, the classic threads in Java Lang thread. That's okay, but it is not the best of the optimal way to scale database applications, and that's why I'm gonna talk about VTs, virtual threads, and the lightweight JDBC calls with the Oracle JDBC driver 21C. Oracle has instrumented that driver to support virtual threads, and that's a fantastic option. On top of that, we have what we call JDBC reactive extensions. It is good because it allows you to perform asynchronous calls, and have a non-blocking, I would say, approach to database development. And on top of that, we also have R2DBC. R2DBC at a higher level, it simplifies the way that you can work with reactive strings. It is an opinionated, I would say, API. It started with a company acquired by VMware, if I'm not wrong, called Pivotal. But we have our own implementation. And if I have time, there's a fourth option as well called RSI, the Reactive Strings Ingestion API that I can show you today. I have a cool demo concerning that. But at the end of the day, if you think about the virtual threads and the demo that I have, you'll see that it is not about specifically response time, but I would say better use of your hardware resources and somehow scalability as well. And with R2DBC, and the strings, you can apply many different operators. For example, it is non-blocking. There are so many different reactive frameworks at the moment, like RX Java, Project Reactor, which belongs to the Spring, I would say, umbrella of libraries. We have Akka, Vertex, Eclipse Vertex, and so on. That's what we'll be exploring today. As you can see here, at the end of the day, your Java business logic as the client code. We give you all the options, and with virtual threads, the good thing is that this project, it does not change the concurrency model in Java. And it also allows you to adopt virtual threads without having to refactor your existing code, and that's a good thing. Okay, so let's talk first then about these two solutions that are the main topics of my presentation today. First of all, let's talk a little bit about reactive programming. A synchronous database access, as I said, with non-blocking network I/O. We have the Oracle R2DBC driver, also JDBC reactive extensions. In the middle, and also reactive strings ingestion. That's a very interesting option as well because it uses many specific features of the Oracle database, like a rack clusters, real application clusters. Also, there's I would say, a powerful feature called the React path insert. So we can somehow in explaining that in an easy way, batch all the records and insert then I would say bypassing the entire SQL mechanisms. So this is a direct insert, and append to the, I would say, data structure that is stored by the Oracle database. So it delivers, I would say, fantastic performance for applications like, big data applications, streaming applications, IoT applications, smart cities, that you have to ingest, I would say, humongous amounts of data. And with reactive programming, I'm not sure, but you've heard about a reactive programming. It is good because it is asynchronous. There are many good libraries supporting that, as I cited previously. Reactor, RX, Java, Akka, Vertex, and Project Loom. As an umbrella project, we have a structured concurrency and virtual threads. It allows you to have a kind of synchronous approach to database access, but now with lightweight threads. It is a combination then of standard JDBC with virtual threads. And as I said, you don't have to redesign and refactor your existing code, because at the end of the day, the new methods and the way that you can instantiate lightweight threads with the factory or the specialized methods that now belong to the java.lang.thread class, they are there for you. So at the end of the day, we are talking about the very same class. Um, And the libraries, they somehow have to be compatible with virtual threads. So Oracle has instrumented the Oracle JDBC 21C driver to support virtual threads. Okay, let's talk a little bit about the classic Java platform threads then. Okay, as I can say before JDK 19, kind of preview API, so in case you want to execute the demo that I have here today, and I can give you access to the code, you just have to enable the preview switch, command line switch, or some IDEs, they offer you some extensions that you can easily do it. I can show you, for example, I'm using Eclipse here today. But the classic blocking threads, they block, I would say, for hundreds of milliseconds, and they follow a thread per request style. So there's actually what we call the classic of platform thread allocated to a given call, and that's quite expensive in terms of resources. Because at the end of the day, it also maps to the OS thread, what we can call kernel threads. The thread count then increases linearly, with the number of JDBC calls that you perform. So it is not the best way to actually achieve better throughput and scalability. And this performance degrades, given the number of threads as you have more and more clients, or I would say SQL queries being executed. In terms of the internal allocation, the JVM, the stack, even the heap and so on. You can see memory. There's, I would say, a demanding, I would say, need for memory here in terms of the allocation per thread. And scheduling, on a single CPU is also expensive. Even concerning, I would say, CPUs with multiple cores. My machine, for example, I have 4 cores and 8 logical ones, and I'll show you during the demo how demanding that is. Reactive programming is a good option as well, because we can, I would say, execute the calls in a non-blocking way, as I said, on a synchronous request. But at the end of the day, to process a single request, usually there are many threads involved, concerning the different operators that you can use and apply and so on. um, they are also somehow difficult to debug, because the async calls, they are executed in different threads. Even concerning the Fluent API and the way that these calls are composed, sometimes it is difficult for you to debug the applications in case you have issues. In terms of skills, there's a kind of paradigm shift, react with reactive programming and functional programming as well. And don't get me wrong, I think those are great things. It is just a matter of simplifying the way that you can achieve the same scalability, and I would say save resources with virtual threads. And they are also mid to long term harder to maintain. Okay, so the solution is to use virtual threads. As I said, we have this Java enhancement proposal 425 called virtual threads. Now, concerning JDK 19, it is a preview API that you can use out of the box. You just have to install JDK 19. You know, these lightweight threads, they will dramatically reduce the effort of writing, maintaining, and observing high throughput concurrent applications. Virtual threads, they enable applications written, still with a kind of simple thread per request style to scale with optimal hardware utilization, and that's my what my demo will prove as well. Existing code, we are talking about the very same Java lang thread API, so this is what you have to use in order to adopt virtual threads with minimal change. As I said, it is not, I would say, about humongous effort to refactor everything that you have, related to concurrency and multi-threaded applications. Troubleshooting is easier as well, debugging, profiling, and so on. And the good thing to talk about here, virtual threads, they don't remove the traditional implementation of threads, as I said, and they don't alter the basic concurrency model of Java. So just to allow you to fully understand what I'm talking about, there's a graphical representation here, this block diagram. So you can see the virtual threads at the bottom, and the Java platform thread, or a carrier thread, as we can call it. At the end of the day, this is the platform thread. So now, instead of allocating one platform thread per call, the virtual threads, they can share the very same platform thread, and that's mapped to the OS kernel thread. As I said, the JDBC driver is now instrumented to support virtual threads. Um, the API, is the very same one when you consider concurrency, executors, thread factories, and so on. And it runs on top of Java 19. So you remember, you have to install JDK 19 in order to, I would say, try it. So let's run this first demo here now. I have Eclipse here. So first thing, as I said, you have to enable it. So provided that you have Java 19 installed, you just have to make sure that you will point to the right Java compiler. So you can see 19 here, with the release option enabled. Same thing if you check I'm using Maven as a build tool. If you check Maven here, you can see that my compiler target uh, is and source. I'm talking about version 19, and of course the Maven compiler plugin. I'm using the enable flag here as well. This is something that you can also run from the command line. So, but as I'm using an integrated development environment, it is easier for me to use these plugin. But okay, let's then execute first 1 million virtual threads, and you are hearing it right. Okay, so I'm talking about running 1 million threads, and I have my laptop here. It is not a server, okay? The only difference, you can see that there are some, I would say, utility methods that now belong to Java lang thread, and I'm using this specific one. Start with virtual thread. If you check the traditional platform thread, you'll see that I would instantiate with the no, with the constructor, and you can see the new keyword here, a new thread. And I have 1 million threads here, but it's impossible to run 1 million platform threads with my laptop. But let's execute this one first, and I'll do something here. Let's open Task Manager and check the Performance tab. You can see that I have 3,000 threads here, okay? And then I can execute this code. It is very simple, this demo here. I just will print the thread number, and actually there's a sleep here, 2 seconds, just to simulate some IO or database communication or something like that. I have the same examples here with database queries. Um, but of course, let's run this one here and then show you what happens first. So let me execute this Java application. It started executing here. You can see that, I still have 3,400 something threads here, and I'm executing, and you can see the number of threads that I started. So I started 1 million threads here without impacting my the number of threads, memory is okay, CPU, and so on. And it is I have this join here, so just to give the I would say the threads the opportunity to execute. 28 seconds elapsed, and you can see that okay, the application is finished. So let's do the same thing now with platform threads. At some point, I'll have to stop because otherwise my talk will be interrupted, because my laptop and Eclipse and the entire OS will, I would say, halt and be locked. But let's do it again now. So let me clear this console window here, and let's run platform threads now. I'll keep 1 million threads here. It is basically the same code. The difference is that I'm using a platform thread now. So let's do it, and let's inspect what happens here. And you are seeing that now I have 14,000 platform threads here, and I'm still processing 28,000 threads. And there are some points and some moments here where the thread execution is hanging, and you can see, okay, sometimes the GC is acting here and I would say doing the job of, I would say, retrieving memory and recycling the resources. But at the end of the day, you can see that it is more than, I'm still processing 120 something thousand threads, but it is more than first 28 seconds. It is not about response time but throughput, but at the end of the day, there's, I would say, a positive side effect or negative side effect depending on your perspective. But you can see the number of threads here now, 3 times, 4 times more. I'm gonna stop it now because I don't want to I would say uh, um, have my talk finish it and interrupted here, as he said. But you can see the difference then. So why and how it is interesting for you um, to use virtual threads. I think I have which one is this? Maybe I have another implementation that I would like to show you. Maybe, yes, this one here, for example. It's quite easy to instantiate a virtual thread. As I said, you can use this specific method here, is start virtual thread. you know Another one, the thread class. Now you can out of the box also use this one. You just say, I want a thread of virtual, and then you have a virtual thread, otherwise thread of platform, and you get a platform thread. Okay. So remember about that. Okay. And then we can do the same thing now with JDBC. Okay, so I have just a single query here to retrieve a single record. I have platform threads here, and then I have also virtual threads. Let me close this one here. But let's do it with platform threads again. Okay, now with JDBC, it's just I have a database connection here, and I just execute a simple query, do SQL work. Um, okay, we return to 3,000 threads here. This time, given that I have database access, I'm running 1,500 threads. I can interrupt it at some point. I just want to show you again, in terms of resources, how demanding that is. So let's run it again now with a SQL query. Um, Okay, so I have the queries being executed here. There's a counter here somehow, at some point it can be different because the execution, and I have, the start and the join here. So it is not fully deterministic in terms of the execution. It depends on the OS. If we have Windows, for example, as I have here, which uses time slicing, or if you are running Linux OS, which uses preemptive scheduling. But at the end of the day, you can see that the number of threads is increasing here now again. So that's the thing. That's why it is good for you to use virtual threads. And the good thing, remember, is that this project here, I can show you JDBC driver with virtual threads. You will see that in order to execute um, the JDBC queries, I'm using the Oracle database. So you can see that I have the dependencies on the JDBC jobs for the Oracle database here. The production one has all the required, I would say, libraries inside of a single jar, and that's a good thing. But you can also configure it in a different way if you want. For example, just to give you a glimpse of what I'm talking about, if you check this project here, which is another API, if I have time, I touch it briefly. But this Pound, for example, instead of using a single jar, I configure the Jdbc library along with some or the specific Jdbc 11 driver and so on. Okay. Okay, but let's proceed now with the presentation. So remember, virtual threads, you should pay attention to this, I would say, preview API. It is a very good thing that happened with Java, because now, if you combine that, for example, with native execution and GraalVM, you have lightweight threads, so you can make a better use of your hardware resources, everything, processor, memory, and so on. And with native compilation, you can really achieve native performance in comparison to other programming languages like C, C++, Rust, and so on. Java is on par now at the same level if you consider what you can get with these combinations. Okay. Um, Okay, so let's proceed now and talk about Reactive Jdbc. Um, and synchronous and asynchronous JDBC. So the synchronous way of, I would say, executing queries, you can see here, set up a blocking call and then handle result, so you send the query is executed by the RDBMS, the database management server, Oracle, and then you have the result set and you handle the result. With reactive, it is different because you send a non-blocking call, so it's a kind of file and forget approach to it, and then you can handle the result, as a string, and apply some operators and so on. When you consider synchronous and asynchronous, I know that you are developers, but if you think about it, I can explain that if I send a synchronous messaging would be a situation like I send an email message and I stay in front of my laptop waiting for a reply, so I'm blocked here, and waiting for the person that I'm trying to reach out to reply, and then I can't do anything else. I'll keep waiting for the reply. And non-blocking, or a synchronous approach to it, you send an email message and you go grab a copy of tea or something like that. You don't have to wait for it. Okay, so this is how it works. So talking about this transition from synchronous to a reactive JDBC, in terms of executing queries, you can see here on the left-hand side the traditional JDBC API. So you have everything that you may be used to, like a SQL statement, and then you can execute your query. You have a result set, you process the result set, and that's it. With R2DBC, it is different because then you can see by the way, the R2DBC service SPI here, provider interface here, so, and we have an implementation of this contract concerning the Oracle database. And I'm including the links for you as at the end of this presentation. So we have Flux here, so you can create a statement, execute it, it is non-blocking, so you have the reactive strings and the entire string being returned, and then you can apply some operators, process, extract what you want. But at the end of the day, this is not synchronous but asynchronous. um, just to give you a glimpse of how it works, then, as I said, we have the Oracle database at the bottom. As I said, the R2DBC driver is a good one because it abstracts all the complexity concerning this interaction, and you can combine it with the mainstream reactive frameworks, as I said, Project Reactor, which is under the Spring umbrella, an ecosystem. But also you can use RX Java, Aucun, Vertex, Eclipse, Vertex, and so on. And you have to run Java 11 plus, runtime environments, and use the proper JDKs to use this one. So I have a very simple demo here again concerning R2DBC, just to show you how easy it is to use it. What is it? Maybe here. Yes, this one. Okay, so just to allow you to understand, and as I said, if you check mono or flux, depending on the approach that you want to work with, reactive strings, at the end of the day, we are talking about the flow API, so we have publishers and subscribers. Usually, you can send data and publish data, but you can also send but this, you can see that these components, they belong to Project Reactor, so it does not have to do with our specific component here. The good, or maybe what you have to pay attention, as I said, is that we are including here the Oracle R2DBC driver, okay, combined with the traditional Oracle JDBC1. And of course, Reactor is here because my example uses Reactor, but it could be RX Java and so on. Uh, but at the end of the day, the way that you can interact with the database is in terms of the complexity of this API from the syntax point of view. it is quite simple. Okay, so I'm using Flux here, for example. So I get a database connection factory here. So I create a connection. I have a connection. So and then I can execute a query. My query is quite simple indeed. And then I execute the query. I get a result, and then I can apply the operators. Then, and at the end of the day, I print it. You can see this is a simple, and I love reactive programming, by the way. But with, as I said, with virtual threads, it is better for you because you keep the very same concurrency model, in the very same API somehow, and it is easier for you to debug. Because if I execute this code here, you will see that for both Mono and Flux, I get the responses here. They are quite performant, by the way. Um, you can see, oh, what happened here? Oh, let me check again. Okay, let's try again. No, it is not working. Why? Oh my God. Okay, I'll check later. But at the end of the day, let me just show you something here. If I set a breakpoint here, for example, and I run it in debug mode, for example, how difficult it can be to actually process or debug. For example, if I want to inspect, and you can see a simple breakpoint here, So if I go to the next one, for example, um, um, and I run it again here. Let me do it again. If you want to inspect the objects, for example, it is not so straightforward as with the traditional model that you have when you use threads. For example, if I want, I don't know, maybe inspect this call here, actually I don't have the context to do so, So you will see that it says it cannot be resolved because the way it is processed, as I said, internally, it depends on many different threads, and the context is not so easy to inspect, debug, and profile. Okay, I don't know why. Let me see what happened here with my database. Just one sec. Let me see if I still have the. Uh, it seems there's something wrong with my connection. Okay. Yeah. Okay. Anyway, let's proceed, and then I will revisit it at some point. So yes, that's my talk and the what I wanted to talk about R2DBC and the R2DBC driver. The instrumentation that we have concerning the Oracle Jdbc driver version 21C and the support to virtual threads in the scope of Project Loom. I'm providing you some links here. The project on GitHub for R2DBC, everything that you may want to explore concerning virtual threads. Our JDBC page has, I would say, pointers to all these projects, And there's a third one, actually a fourth one, that is quite interesting here as well, called Reactive Strings Ingestion Library, okay? This one is nice because, let me come back to my presentation here. Um, and the reactive strings ingestion library is good because, as I said, it uses many specific features of the Oracle database to ingest, I would say, vast and humongous amounts of data from different data sources like sensors, for example, if you consider an IoT application. And this feature, direct path insert, it bypasses the SQL mechanisms, the traditional mechanisms. So it batches the entire, I would say, data set, and inserts it at once, So if you have 1,000, 5,000, 10,000 records, and many, I would say, signals and data coming from IoT sensors, for example, you can do it at once, and that's quite nice. The API is a simple one. So let me close this thing here. Um, this one, yes. So you can see the RSI project here. Let me show you RSI introduction. First of all, um, If you consider the dependencies, you will see that I have the RSI jar here. By the way, as I told you, you can also include the different jars in case you don't want to go with the production one, which comprises all the jars. You can just configure your application with the specific ones. But this is the API that I'm talking about. And the implementation, there are several different ways that you can create your, again, I'm talking about reactive strings and the publishers and subscribers, the Flow API and so on. You can implement your own. You can use the one that is available out of the box. You can use the one that is provided by I would say out of the box, concerning the Java JDK, like this submission publisher here, for example. I'll present to you the simple push publisher that is provided by Oracle. Um, and this one is okay because it is quite easy to use. And then, for example, I have six records here, and a couple of different publishers here. So in order to create a connection, I just need to provide you the traditional and the usual information and the data, the JDBC URL connection, the credentials, the target schema. I can also configure the number of rows that I want to buffer as part of this batch insert, direct path insert, and the duration in seconds. And then I can publish, the records that I want to execute. Let me try to run this query again. Okay, it is empty. So if I execute this code here now, and I think, let's see, okay, it worked. And now I can just go there and run, and you will see that I can get all the records inserted at once. I'm doing that with a controlled data set here, but and I have a couple of blog posts actually that I can show you that explore this API. You just go to my Medium um, 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 page, in my blog, my Medium blog, and you will see that I give you the source code and I explain, the different mechanisms and how they work, the script to create the database, to provision everything, and the different options and components that you can use to explore this option as well. But it is a very interesting one, depending on your application, and it is an open source project. Both R2DBC, the documentation is here. The same thing for this one that I presented now, RSI. And at the end of the day, virtual threads is there as a preview API, as I presented to you. Java 19 is released. Actually, Oracle released JDK 19 in September the 20th, 10 days ago. You can see virtual threads as a preview API here. And we are talking about the Flow API, so very same thing with reactive strings, publishers, and subscriptions. So we give you options. There are 4 different APIs that you can use. Virtual threads is, I would say, an amazing option that Java developers have now, and the Oracle JDBC driver does support it. That's everything from my side. So I'm gonna stop sharing my screen now. And so I want to give you the opportunity to ask your questions. Okay. And once again, thanks a lot for joining us today. And do we have any questions?
I guess it's clear for... Do you hear me?
Yes, I do.
Yeah, I guess it's fine. So thank you very much.
My pleasure indeed. Thanks a lot. It's an absolute pleasure to have this opportunity to talk about the things that I'm passionate about, Java and database development. Thank you very much.
For see you. Bye.
Bye-bye.